Alright, something a little bit more exciting and fun today. I just picked this up off of good old Facebook Marketplace, and 1.5 hour drive to collect it and back again, but nonetheless there it is. It's a dual wind turbine solar panel generator setup. So the guy was telling me that I bought it from that an old fella on the other side of the country used to make these to order, custom, whatever you want to call it, and you can't actually buy a setup like this. So we're going to rip into this thing and see what it's all about. First thing I want to do is find out what kind of generators he's used here, because these are cogless generators and they have zero drag on them, so I'm not sure what they've used in there. I can't see a regulator anywhere, simply the output from one generator and the other generator and the solar panels all married into one from what I can tell, and then goes into a Anderson plug, or some long cable, and then an Anderson plug. And the guy that owned it used it to keep the batteries charged in his caravan while he was off-grid camping, just to assist along with the solar. Because he was always camped on the coast, there was plenty of wind, so the two little generators did their job. My first impressions are that I don't like the blade overlap. It would seem to me that the blade in front would interfere with the blade at the back as far as maximum efficiency goes in the available wind that there is, because the blades overlap, as you can see. The little solar panel, didn't even know they made them back then. There's a little flexible solar panel. This was made in 1987 apparently, and by the rust around the screws and that, you can see it's been close to the ocean. So a very tired old solar panel. Now it does have what I think is a big crack going along here. I've got to have a good look at it. So it may have been dropped on this corner and snapped it right the way through. Not sure, but that doesn't matter, because we're probably going to rearrange this a little bit. And I just so happen to have a couple of brand new Renogy 20-watt solar panels. So the blade overlap I don't like, so we're probably going to make another frame to carry this setup. The other thing it doesn't have any slip rings at all, so that means that the cable could get tangled up around the pole that's holding it. And I just made this quick little stand to sit it on. If we turn it upside down, have a look on the underside, like so. You can see we've got our little fin at the back to point it into the wind, and we also have wires down in there joined together, popping out the side, and this is just made of PVC pipe and T-pieces and all other sort of stuff. On the motors I can see wind search on eBay, and this just looks like a tape, cloth tape, so we should be able to peel that off, undo the screws that are sticking out here, although there's no sign of them on the back. We do have some on the side, so we may be able to undo them, separate the PVC housing, but it just looks like it's been made from all these widely available plumbing parts from the local hardware store. And being the guy was a backyarder, didn't do it for a living or anything, just made it up for people that wanted it. That's not surprising. These actually look like 100mm end caps for stormwater and what have you, but I'm going to pull it apart. I want to see what kind of generators they've used in here. He said they are brushless, which means they have to have some sort of rectifier in them, and he also said the regulator's built in. So that's what he's telling me. They're a brushless generator, and I cannot feel any drag whatsoever on that thing, so that may well indeed be brushless, but very old. Gonna dive into it, have a look, see what it's all about. Okay, just a bit more info. The blades are a carbon fibre, as we would expect. These parts look like they came from the hobby shop to hold the blades on, or the propellers, whatever you want to call them. Now, there's what we found inside our drums, and the motors they're using, I don't even know why I didn't think about it, are the three-phase drum motors from large printers and the likes. So nothing special there. Inside here, try and get some light into it, I can see capacitors and inductor down there and all sorts of goodies, but it's all been glued in and I can't get it out. So now we make the decision whether we completely strip this thing and rebuild it, space the motors a little further apart so there's no interference of one blade overlapping the other, or we put it back the way it was. I kind of want to pull it right down and rebuild it. These are, just like I said, end caps for 100mm stormwater, and they haven't done a very good job in here when they've cut the pipes. I don't know what they were up to, but of course you can't see that once it's all screwed together. And yes, this is only a cloth tape, so these were made in a backyard, so you mightn't expect much more, but I would kind of like to take the time and make this thing pretty. I did give this one a spin up with the drill, and just the one motor, and I can get 14.95 volts across it, and dead short current was 2 amps. Of course it's not going to be that once it's up at 14.95 volts. So if it's spinning fast enough, it will charge a AGM or lead acid battery, no problem there. And while spinning this one, I spun that one as well, and it made no difference to the voltage. So these are obviously linked in parallel and not series, as one would have thought. So I think I'm going to strip the whole thing down and start again, go and buy some new pipe, space these generators out so the blades do not overlap, and replace this old solar panel with a new one, make it all workable again. But that's how it was made many years ago, simply using these three-phase drum motors from the likes of big printers and stuff. So, and that's why there's no cogging, because these motors do not have any cogging. Ingenious. And it's what's it, about a 2.5-inch drum, I would say. So he said he thinks it had a maximum power of 100 watts. Now I'm not sure whether that's from both the generators and the solar panel, or just from the generators, because the solar panel wouldn't be any more than 10 watts. So I would say all up it would be 100 watts, because these little things here wouldn't put out very much either, I don't think. So this would be a trickle charge setup, just to keep your batteries topped up while you're not using them, I guess. But nonetheless, it was good to find out what was inside, and I will come back and do another video once it's had the big rebuild, and we'll stick it in front of my big blower and see what we get out of it. This just gets better and better. I managed to dig this out of there with the screwdriver. It was all siliconed in there, silicon to the wires, crap everywhere. Now this looks like a buck boost converter, because a buck or a boost by himself have the 2 pots. This one has 4, so I'm guessing it is a buck boost converter. He's also got a diode on the output to stop feedback from the battery, And I know exactly why he does that, because if you don't have this diode and you plug the battery straight into the output, this little LED here stays lit up. So whether the wind generator is working or not. By putting this diode in here, the little LED doesn't light up because power can't be fed back into the unit from the battery. So just sheer luck that I've been doing the same experiments with lithium ion battery packs using buck converters to bring the voltage down to 12.6, and I had the same drama with this connected to the battery. The LED light stays on. So by putting a diode there, we stop the LED lighting up when there's no power coming in from the wind turbines or the solar. And not that it'll drain a large battery down very fast, but I would say that's why he's done it. Okay, so I thought that was it. No rectifier in there, but thinking about it again, these little motors have their own board on them. I can't see very well in there. They've got their own circuit board in there, and I believe it is rectified from that board, which doesn't make much sense because there's still 3 wires coming out of it, which would indicate 3-phase. So I'm going to have to dive into that a little more. So I thought that was the end of it. We found our buck boost converter, no problem there. So that acts as a regulator as well to regulate the voltage. I'm going to go and stick it on my power supply, see what he's got everything set at. But upon pulling this cover off, so I could retrieve the wires out of there, which I thought were just joined to these ones, I find inside another buck boost converter, or I believe it is. It's either a buck converter, a boost converter, or a buck boost converter. So there's another one in there, which means there's probably another one in here, unless this one here that was in there was for this motor here, and that one that's in there is for this motor here. So I'm definitely going to have to pull this right down and simplify things a bit, because this is getting all too complicated with all these buck boost converters hidden everywhere. So I'm going to pull this one apart now, see if there's one in there, and I'll come back and let you know what I find. Okay man, this one's getting, it's just way too complicated. So we had this buck boost converter in here, then we found another one behind this motor here, which I think you can see in there. I took this motor off here, I found another one in here. So this has got 3. I'm going to have to pull these 2 out to see exactly what they are. They may even be some form of 3-phase rectifier, because I don't believe the rectifiers are built into these boards on the motor, because there's still 3 wires coming out, and if it was rectified we'd only have 2. Here we go. Didn't see all that writing on there. 26 volt, 3 amps. Oh, there you go. So I'm going to pull this one out and that one out, see what they are, and we're going to just remake this all together, because there's no need for all those components that they've got in there. We're going to do it a lot more simpler than what they've done here. This is just, yeah, way too much. So I'll dig them 2 out if I can, and we'll come and see what they are. Okay, check it guys. 3-phase out. I found the rectifiers, they were in behind these buck boost converters. So from our motor through our 3-phase rectifier into one buck boost converter, from the other motor the same, 3-phase rectifier into the buck boost converter, out of that buck boost converter and out of that buck boost converter into this buck boost converter, and then out to our output power to our battery. So we have in total 3 buck boost converters. I'm pretty sure that's what they are, because the boost converters and the buck converters only have 2 pots, and I'm pretty sure the buck boost converters have 4. So you can set your maximum voltage in and minimum voltage in, then maximum voltage out and maximum current out. I'm pretty sure that's how these ones work. I'll have to have a look, see if I can find some numbers on here. And so we've got a brand, maybe. Oh, there we go, there's a number, so I'll be able to look that up and see exactly what they are, but I'm sure they are buck boost converters, which would make this work at very low speeds, which is a really good thing. The solar panel also went into the secondary buck boost converter, and that would also regulate the output of the solar panel at the same time. So it had the output from that one, the output from that one, and the output from the solar going to the input of the third one, and then the output went to your battery. An awfully complicated way of doing things, but nonetheless that's how it was done. We don't need to do it like that. So now that this is this far apart, I'm going to go ahead and just redo the whole lot the simple way, because we only need one of these and our two rectifiers. We don't need these second lot of buck boost converters. Alright, that's long enough for this video. That's what I found inside this old U-Butte wind generator, and these really don't look that old, so it was either well sealed or this was not made back in 97 or 87, whatever he reckons it was. This looks a bit later technology to me. Anyway, let's give it a rebuild and make it work. That'll be in the next video. So thanks for watching, guys, and that was a bit of excitement finding all that garbage in there. Okay, so we looked up this board. It is a buck converter, so it takes a high voltage, converts it down to a low voltage. That's fine, but it's also a MPPT charge controller apparently, but upon testing it, it's very limited, and it's a manual adjustment on this. It has no doesn't have the brains to actually actively track maximum power point. It's a manual adjustment, and that's what you're stuck with. So have a constant voltage adjustment here, or a voltage adjustment, and a constant current adjustment with load. And this one here apparently is constant current without load, whatever that means. Don't think you'd get any current if it didn't have a load on it. And this one here is your maximum power point tracking adjustment. So you adjust your panel voltage, you could say, in order to get maximum power out. But like I said, doesn't have the smarts to actively track maximum power point. It's a manual job. So basically it's just a buck converter with a bit more bullshit on it. So that's what we've got. But we only need one of these. I don't know why they have the three. Secondly, this diode does stop power feeding back in, and they also say you have to have this when you're charging batteries, otherwise it'll blow the unit up. So haven't managed to blow any of mine up yet, but I did manage to stop the LED coming on when there was no power going in, because without that diode, as I said, the LED stays on. So now I better make sure that I always use a diode if I'm going to be charging batteries with it, which I do anyway, to stop the LEDs running all the time. So there you go, we've got three of those U-Butte numbers in the one machine, and we simply don't need all that. We just need our two rectifiers. Don't have to worry about the output from the solar panel, that's already rectified, because the solar panel is simply a big rectifier, or a big diode should I say. You can't pump power back into them. They're a direct current out device. So we don't need any rectification for our panel. only for the 2 motors or generators. So if we couple all 3 of those up to the out input of one of these, then the output along with our diode will go to our battery to charge it. There's no need to have these other 2, one for each motor. Very pointless. Okay guys, yeah, I'm going to go and build this, so we'll see you next video when this is all done.